Now let's look through the solutions to the two homework questions I gave you last Friday. So yesterday, of course, you were doing some work revising and practicing with completed square format, and then I asked you to do I'd already asked you to do these questions, of course, as well. So do let me know if there's parts of completing the square that you're still feeling a bit shaky on, and we can definitely spend more time on it if we need to. Okay, in question 5, we're asked to find the points where the graph y equals x squared plus 4x minus 5 intersects the x-axis and the y-axis. So let's do the y-axis first. And the y-axis means x is equal to 0. And of course, that's just going to be the constant value because this will go to 0 and this will go to 0. So you can write it down straight away. Y equals minus 5 is my x-intercept. Then I want to find the x-axis, which means y is equal to 0. And that means I need to solve x squared plus 4x minus 5 equal to 0. I can use the minus b formula, or I can factorize it by finding two numbers that add to give me a plus 4 and multiply to give me a minus 5. And then each factor in turn equals to 0, so either x is equal to minus 5 or x is equal to 1. Let me just check that I've answered that in the format that they've asked. They asked me for the points where the graph intersects the x-axis and the y-axis, and I haven't done that. I haven't written them in coordinate form, so I wouldn't get my full marks until I write them down like this. So those are the 3 points where the graph intersects the y-axis and the x-axis. The second part of the question asks me to write my equation in the form x plus a all squared plus b. Now, if you were following those notes videos from yesterday, from Monday, you'll have seen I used h and k here. So it doesn't matter what these letters are. I square out my brackets and I get x squared plus 2ax plus a squared plus b. And I know that this must be the same as x squared plus 4x plus 4x, I don't know why I wrote that down, twice plus 4x and then minus 5. You know what, I'm just going to write this out again. I can't find my Tipex. So that's x squared plus 2ax plus a squared plus b, and that's equal to the original function that I have up here, x squared plus 4x minus 5. And I have this lined up nicely now. I can see that the x squareds are the same. And next I look at the x terms. So from the x terms, I get that 2a is equal to 4. So I'm just comparing their coefficients there, which means that a is equal to 2, dividing across by 2. And then I look at my constant term, and the constants have no x value in them. So from the constant, I can work out that a squared plus b is equal to minus 5. But of course, we already know what a is. So if we square that, 2 squared is 4, plus b is equal to minus 5. So b is equal to minus 9, bringing the 4 across and changing the sign. So that means that x plus a all squared plus b is actually x plus 2 all squared plus b minus 9. Okay, so that's my function. And we know that it's u-shaped because of the positive x squared, and therefore it has a minimum. And that minimum point, we change the sign of the one in brackets, and we don't change the sign of the other one. So there's my minimum turning point. So they said, write it in completed square format, which we did, and they asked us to write down the coordinates of the turning point, which we have done as well. And the final step was to draw a sketch of this function. So we know that this function goes between minus 5 and 1 on the x-axis, and down as far as minus 9 on the y-axis. So most of my graph, I'm even just doing this without a ruler, most of my graph will be below the x-axis. That's my y, that's my x. 1, 2, 3, 4, 5, 6. 3, 2, 1. Minus 1, 2, 3, 4, 5 is minus 5, minus 6, minus 7, 8, 9, minus 10. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. And we might as well fill in 1 and 2. So you don't have to put in every single number when you're doing a sketch of a graph like this. The important points were y equals minus 5 was my x-intercept. X equals minus 5 was one of my roots. X equals 1 was the other one of my roots. And minus 2, minus 9 was my turning point. And you know, when you fill in the points like that, you can see that your calculations are correct. Like if this was over here somewhere or over here, I'd know that I'd made a mistake in my calculations, so then I could fix it. So then a sketch of the graph, we know that it should be U-shaped. There's the turning point down there, and there's the graph of our function. Okay, question 6 was similar. So let's take a look at that. It asks us to write an equation of quadratic in completed square form. So for question 3, we're asked to write x squared plus 3x minus 10 in completed square form. So we know that it's going to be, you can use whatever letters you want here. I'm going to stick with my h and k because it's what we're familiar with from the notes. And we get x squared plus 2hx plus h squared plus k. And that's equal to x squared plus 3x minus 10. And then the x squareds are fine. My x terms give me that 2h is equal to 3, which means h is 3 over 2 or 1.5. It makes a nice neat decimal, so I will write it as a decimal. Then the constant terms, might need to use my calculator here, tell me that h squared plus k is equal to minus 10, but h squared is 1.5 squared, so that is 9 over 4 or 2.25. Let's just double check it. So 1.5 squared is 9 over 4 or 2.25. So 2.25 plus k is equal to minus 10, and k is equal to minus 12.25. So because these are nice neat decimals, I'm just going to write them in decimal form. It makes it a bit easier to write it. And so we can say that this function can be written as y equals x plus h, x plus 1.5. You can use fractions as well and you'll get full marks. Plus k minus 12.25. So that is the answer to that part of the question. Hence, write down the coordinates of the turning point. So the turning point, and we know it's a minimum because this is a U-shaped graph. So let's just write down that it is a minimum. And that is going to be, I change the sign of the 1 in brackets, minus 1.5, and I don't change the sign of the other one. There's the coordinates of my turning point. And finally, draw a sketch of the curve indicating clearly where it intersects the x-axis and the y-axis. So again, I need to do the work to find the roots. The y-axis is going to be at y equals minus 10. That's the constant term here. The x-axis comes from the roots of x squared plus 3x minus 10. So that's x plus 5 by x minus 2 when I factorize it. So x equals minus 5 and x equals plus 2. If there's a step here that you're not sure where I got something from, please do ask me. That comes from factorizing this. And then I draw a sketch. I know that I need to go down as far as minus 12.25. So again, most of my graph here is going to be below the x-axis. I could use a ruler, but I'm just doing this nice and quickly. So I'm going to go double width on my x-axis, because why not? 1, 2, 3, 4, 5, 4. 1, 2, 3, 4, 5, 6. I don't need all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These should be negative. 11, 12, 13. So sketching the relevant points, it intersects the y-axis at -10. It intersects the x-axis at x equals 2 and x equals -5. And my turning point, my minimum point, is at -1.5. So there's -1, there's -2, there's -1.5. Down as far as -12.25. So I'm just a quarter of the way through the box. So there's the 4 points that I need. There's my turning point, so everything is symmetrical around that. We know it's U-shaped because the x squared was positive. And there is the graph of our function. It was a sketch, so I just went quickly. But actually, putting in these 4 points is usually what you need when you're asked to draw, which gives more points. So watch out for those words. Draw means you need to be really careful and detailed in your graph. Sketch means you can go quite quickly and you don't have to provide as much detail in the graph. Okay, so hopefully that makes sense. Do let me know if there's something that you're still not understanding in this topic. Thank you.